So in our previous class, successfully we have completed OSPF protocol. IP routing, routing activities, routing conditions, routing types like static, dynamic, default. So we're done with static routing and dynamic routing. In dynamic routing, there are two categories. IGP, Interior Gateway Protocol, and EGP, Exterior Gateway Protocol. What are the IGP types? Distance Vector Protocol, Link State Protocol, Advanced Distance Vector Protocol. So Distance Vector Protocol is RIP, Link State Protocol is OSPF, Advanced Distance Vector Protocol is EIGRP protocol. So we clearly discussed about RIP protocol and OSPF protocol. We'll do one thing today. We'll try to compare three routing protocols. Okay. So let's start with Distance Vector Protocol. Distance Vector Protocol is RIP. RIP stands for
Routing Information Protocol.
good. It's Open Standard Protocol. What do you mean by Open Standard? Open Standard means what?
Does not belong to any proprietary.
Yes. So it's support for multiple vendors. And Bellman-Ford algorithm. The classless routing protocol. What do you mean by classless routing protocol?
It can have
Be any
classes or
classes.
subnets.
It can support for subnetting, right? Classful routing protocol does not support for subnetting, and classless routing protocol support for subnetting. And how RIP protocol will choose the best path? What is the metric of RIP?
Only on hop count.
Only on hop count. What is the maximum hop count?
15.
15. And RIP sends multicast messages using 224.0.0.9. And what type of updates in RIP protocol?
Periodic.
For every how many seconds? 30 seconds.
30.
And update timers. Updates are every 30 seconds. Invalid after 180. Flush timer is 240. These are RIP timers. But good thing is in RIP protocol is load balancing. It can support for load balancing when the hop count is equal hop count load balancing. AD value. Administered distance is 120. It's all about for RIP protocol. Next, link state protocol is OSPF. OSPF stands for
One shortest path first.
Open Shortest Path First. Right. It's also open standard SPF algorithm. Classless routing protocol support for subnetting. And metric of OSPF protocol is cost. What is the cost formula? Yesterday I clearly explained about cost calculations.
10 power 8 by bandwidth.
Okay. And how we can write that formula?
Reference bandwidth by actual bandwidth.
Yes. Reference bandwidth by interface bandwidth. What is the default reference bandwidth?
Right.
100 Mbps.
100 Mbps. Yeah. So good thing in OSPF protocol is it support unlimited hop count, and OSPF will send multicast messages using 224.0.0.516. Updates are incremental. What do you mean by incremental updates?
It changes its take update.
Whenever there is a change in topology, then only update. No changes, no updates. It's not like a periodical updates. And even OSPF protocol supports for hello packet mechanism to discover the neighbor, to maintain the neighbor, to terminate the neighbor, right? So hello packet times are 10 seconds and 40 seconds. Even OSPF supports load balancing for equal cost and AD value is 110. Administered distance is 110. In OSPF, so some advanced level topics we discussed like router ID, wildcard mask, OSPF 7 states, and OSPF hello packet parameter. Anyone remember what is OSPF hello packet contains? What are the parameters OSPF hello packet?
ID, network ID,
Area
subnet
ID,
mask,
network ID,
subnet mask.
subnet mask. Hello and read interval timers authentication is optional, right? Yes. And OSPF cost calculation and OSPF packet types. So what are the OSPF packet types?
Database description,
Packets,
limited,
database
Hello
description,
packet, DVD packet,
LSR,
LSR,
LSP,
LSA, CK.
LSU, LSACK. Link state request, link state update, link state acknowledgement. Commonly, two basic hello packets are hello packet and DVD packet, right? And OSPF single area and multiple area. Like single area is divided into multiple areas to minimize the database table size and to improve our network performance and router performance. Areas are designed. And there is a rule in OSPF, one area should be backbone, which is area 0. And remaining all areas we call what?
non-backbone.
Non-backbone area. So a router which belongs to area 0, that router what we called? A router which belongs to backbone area, which is area 0, that router what we called?
Backbone router.
Backbone router. A router which belongs to non-backbone area or the router which belongs to regular area, what we call that routers?
Router.
Internal router, IR. A router which connects to different areas, that router what we call?
Area border router.
Area border router, ABR. A router which enables communication between two different protocols by
ASBR.
redistributing. We call it is ASBR, Autonomous
Autonomous
System
System
Boundary Router.
Border Router.
Yeah. So it's all about OSPF protocol we discussed. Well, good, man. So now compare to RIP protocol and OSPF protocol. So which protocol has more advantages compared to RIP and OSPF?
OS,
Obviously, OSPF has more advantages, right? Yeah. Now let us compare with OSPF and EIGRP protocol. Advanced distance vector protocol is also distance vector, but it's advanced. And EIGRP, enhanced interior gateway routing protocol, is also open standard, but it was Cisco proprietary protocol in before 2013. And algorithm name is real algorithm. Classless routing protocol, support for subnetting. And metric is composite metric. What's the meaning of composite metric? So composite metric, see, RIP protocol will choose the best path based upon hop count only. Only one metric weight, only one parameter. Even OSPF also will choose the best path based upon only cost, no other parameters, only one metric weight. But EIGRP protocol will choose the best path based upon the bandwidth, based upon load, delay, reliability, and MTU. These all parameters are included. So EIGRP will check how much speed on the link. We have a multiple paths, multiple links. So first link, how much bandwidth, second link, how much bandwidth, or link. Not only bandwidth, it will not decide based upon bandwidth. It will check how much traffic on the link. I mean, how much load on the link. And how much delay, like amount of time to reach a destination, how much time is taking, how many milliseconds is taking it. Is also be considered. Reliability, any packet loss in first link or second link, if it is loss, how much loss, it will check it actually. And packet size, we call MTU, maximum transmission unit size, MTU, is all parameters EIGRP protocol will consider to choose a best path. We call it is composite metric actually. And maximum hop count is 255 is also good. 255 means very large network actually, right? But RIP maximum 15. Of course, OSPF supports unlimited, but EIGRP is also good. It supports 255. Multicast IP is 224.00.10. 9 RIP, 10 EIGRP. And The good thing is EHRP supports incremental updates. Like how OSPF supports incremental, even EHRP also supports incremental updates. EHRP is actually a distance vector protocol, but distance vector protocol supports periodic updates, right? But EHRP is modified. It supports incremental updates. When there is a change, then only update. No changes, no updates. Like OSPF protocol. Of course, EHRP is adopted incremental updates from OSPF protocol only. Compared to RIP protocol, OSPF is faster protocol conversation. Agree? And compared to OSPF, EHRP is very fastest protocol. Not only compared to OSPF, compared to all dynamic routing protocols, fastest routing protocol is EHRP. Protocol conversation. If any neighbor down, a neighbor up, that conversation will be very fast actually. Because hello packet mechanism in 5 seconds. Within 5 seconds, EHRP will discover the neighbor, and if neighbor is dead, within 15 seconds, you are no more my neighbor, you are dead. So just 3 consecutive hellos. Hello, 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 3 hellos. 5 seconds. 15 seconds, if not responding, you are not my neighbor. But OSPF, 40 seconds actually. EHRP is 15 seconds. So compared to all dynamic routing protocol, EHRP is very fastest conversation. Load balancing. All 3 routing protocols support for load balancing. So you tell me guys, when RIP protocol supports load balancing?
And hop count is equal.
When hop count is equal, then only load balancing. Good. When OSPF supports for load balancing,
The speed
yeah,
cost is equal.
When cost is equal, then OSPF supports load balancing. Even EHRP supports load balancing for if bandwidth and load is all the metric is equal actually. But very good thing is EHRP protocol, only the protocol can support equal and unequal cost load balancing also. So from so-and-so source to reach a so-and-so destination, if you have a multiple paths, if multiple paths are equal, load balancing automatically. If multiple paths are unequal cost is unequal, then ultimately has to choose only one path, best path, right? But EHRP protocol can support unequal cost load balancing. You want to make use of 3 links, you can make use it. It's a very good thing actually. Equal and unequal cost load balancing. EHRP protocol supports. AD value, administrative distance is 90. Yeah. Now you tell me guys, which protocol has more advantages compared to RIP, OSPF and EHRP protocol?
EHRP.
Yes, EHRP protocol has more advantages. Agree? It supports composite metric, supports incremental updates, and a quick conversation, faster conversation, and supports equal, unequal cost load balancing. Agree? But which protocol we use in real time?
OSPF.
Why? But EHRP has more advantages.
Yeah, limited hop count.
Of course, it's OSPF supports unlimited hop count also, but again there is a design, right? Areas. Each area is recommended 40 to 30 to 40 routers. Point is, before 2013, which routing protocol is best? Before 2013, which routing protocol is best?
PF maybe.
OSPF. Why? Of course, EHRP protocol has more advantages, but
Establishment.
EHRP protocol works in only Cisco proprietary. It was Cisco protocol. After 2013, it's open standard. So then all organizations, all IT companies have started implementing OSPF. They design their network based upon the OSPF topologies. And all engineers are expertised. They have good training and they have expertise in OSPF protocol. Even if something went wrong in the network, they can easily troubleshoot because they have a good experience on OSPF protocol. After 2013, EHRP is open standard. Then, oh, it's EHRP is open standard. Let migrate to OSPF to EHRP over the night. Is it possible? Even it is not good actually to migrate over the night from OSPF to EHRP. So they are running with OSPF protocol only. Existing topology. Let us continue with OSPF. If any new network you want to add, then go with the EHRP protocol to get these advantages. Then existing topology protocol is existing network protocol is what? OSPF. A new network EHRP. Then how they can communicate? ASBR. Redistribution, right? Yeah. So
Yes.
slowly we can migrate to EHRP completely. Both protocols, OSPF, EHRP, both protocols is running in real networks actually. Yeah. Any more doubts? Yes, please. Any doubts? So first link bandwidth it is 2 Mbps link. It is 80 Mbps and it's a 70 Mbps. Now A to H scenario. Scenario is A to H. A is source, H is the destination. In this topology, if I configured static routing, as per static routing, which one is the best path? So we have 3 paths via S00, via S01, S02, 3 paths are available. So if we configure static routing, as per static routing, which one is the best path?
Zero zero.
Why?
Because it's shortest.
So static routing will decide the best path automatically?
No, we have to give it manually
No,
actually.
manually. So best path selection by network administrator. Admin has to decide. Like admin can choose any path. It can be 00, it can be 01, it can be 02. It depends completely admin. Admin will consider any parameters. Admin can look into how bandwidth or look into distance or look into load or security. Might be any parameter actually. That we need to define how the traffic has to be exit. Okay, as per static, I mean as per admin, let's consider 0/2 is the best. It might be a secure, okay? 0/2 is best as per administrator. In same topology, if I configured RIP protocol, then as per RIP protocol, now tell me which is the best path.
Yes, 00. Hop count.
Yes. Serial 0/0 because RIP will choose best path automatically based upon number of hops. Least hop is the best. So as per RIP, 0/0 is the best. In same topology, What if I configured OSPF protocol? As per OSPF, which is the best path?
0/1.
Why?
Bandwidth.
Speed.
Speed metric.
Right. Right, Pramod. So 0/1 is the best as per OSPF because OSPF will choose the best path based upon the bandwidth. Okay. Now, the 3 routing methods are running in my router actually. So I have configured 3. Data traffic is generated to reach to H. So when data traffic will come to A, then static router will say, router A, you use 0/2 path, it is my best path. The same time, RIP will say, no, you use 0/0, it is my shortest path. Same time, OSPF will say, no, you use 0/1, it is a high speed bandwidth, 80 Mbps. So 3 protocols is saying 3 different paths is the best. Then how A can trust which protocol is giving the perfect right information? Static says 0/2. RIP says 0/0. OSPF saying 0/1. Then how A router will can trust it? Yes. Which routing protocol you trust more? Tell me.
Well,
Which one?
the manual one, static one.
Manual static. Why? You know what advantages if we implement the static routing. But devices don't know what is the difference between static and RIP and OSPF. What are the advantages in RIP and OSPF? Devices don't know actually, correct?
Yes.
Then how device can understand and how can device can trust which protocol is more reliable? So this is the cases actually. This type of situation, this type of scenarios, devices will trust more on, depends upon administrative distance of the protocol. So here administrative distance will come in the picture actually. What is the AD value for static routing? I asked to remember all these AD values.
1.
Static routing AD value is 1. RIP 120. OSPF 110. Correct? Administrative distance, RIP is 120, OSPF is 110, EHRP is 90. So now A router will trust which protocol has least AD value, that is a high priority. So administrative distance is the reliability of the protocol. Lesser AD value, higher the priority. Then A will say, so compared to all routing protocols, static is 1. Then I'll trust more on static routing. Then traffic will go as per static routing, which is 0/2. So when there are multiple routing protocols are running in one device, then how device will decide how device can trust which is the best one based on what? Administrative distance. Whenever multiple routing protocols are configured on a router, to reach the same destination, router makes use administrative distance action. That is less AD value, lesser the administrative distance, more the priority. So in this case, a router will trust on which protocol, which routing?
Static routing.
Static routing. What if I remove static routing? Have removed static routing, then
OSPF.
OSPF will come in the picture. Automatically, you can see in routing table, you don't see static routes. You can see OSPF networks actually. We configured RIP, configured OSPF, we configured EHRP. Finally, if we configure static, then which routing you can see in routing table? Static only. So if static routing is configured, then on top of that, if you enable or if you configure any routing protocols, it won't work. Static only works actually. I hope it's clear about administrative distance for everyone. Just
Yes.
understand the scenario. I'm skipping from initially actually. Now we have a clear idea, right?
Yes.
Any more doubts? Good. So successfully we have completed dynamic routing protocols. So let's start introduction part for LAN technologies. This is switching. And routing types are, what are the routing types? Types of routing.
And when?
No, I'm not asking about types of networks. I'm asking about types of routing types. Static routing,
Static, dynamic, and default.
static, dynamic, and default, right? So we're done with static routing and dynamic routing. Now we are starting switching actually. I mean, LAN technologies concepts. The next week we'll re back with advanced routing classes. In advanced routing, we'll discuss about default routing also. Okay. Yeah. In LAN technologies, IEEE engineers have started one project on LAN when networks are started in beginning days, very initial days actually. When networks are established at the time, IEEE engineers started project on local network, how local devices should be connected, what technology is required to exchange the data, I mean, share the data. So they have started working on the LAN technologies actually. So for that LAN technologies, they used one code, project code is 802 project. 802 project means LAN technologies. Under LAN, so they have many technologies are developed. Many technologies under LAN. So any technologies under LAN start with what? 802. If you see code with 802 dot, it can be any number. 802.q, 802.11, 802.3, it can be any. So when the code start with 802, it belongs to which technologies? LAN. Okay. So in many technologies under LAN, the most popular physical layer LAN technology is Ethernet. Have a small introduction on Ethernet. A technology originated by University of Hawaii, later Xerox Corporation has adopted. So Ethernet is the most popular physical layer LAN technology. As per IEEE, Ethernet standards so Ethernet comes under LAN or WAN?
LAN.
LAN.
LAN. So any LAN technology, a code, project code start with what? 802.
Not two.
Dot 3. 802.3 is the Ethernet actually. Later sometime, one more type of Ethernet was developed for fast communication purpose. We call it is fast Ethernet. This is also Ethernet. Then what is the code of Ethernet? 802.3, right? What is a fast? Means difference is the speed. To define the speed, they use code U. 802.3 U for 100 Mbps. Later sometime, one more type of Ethernet was developed actually. What type of Ethernet it is?
Gigabit.
Gigabit Ethernet. Gigabit Ethernet. Is also Ethernet. What is the code of Ethernet? 802.3. It's also Ethernet, right? But it's Gigabit Ethernet. Speed is 1000 Mbps. Code is AB and Z. AB and Z they used actually. Still we have one more type of Ethernet. It's 10 gig. 10 gig ports. 10 gigabit Ethernet. Is also Ethernet. 802.3. AE. So this is entire Ethernet family. These all are Ethernet ports actually. Ethernet technologies. Fast Ethernet, Gigabit Ethernet, 10 gigabit Ethernet, and IEEE standards. Or the speed of Ethernet or
10
802.3
Mbps.
speed, 10 Mbps.
100,
802.3 U speed,
100,
100 Mbps. 802.3 AB and Z speed,
1
1000,
Gbps.
1000 Mbps or
1
1
GB.
Gbps. Like 802.3 AE, which is 10
10
gigabit
Gbps.
Ethernet, 10,000 Mbps, or you can call 10 Gbps. So this is important notes for exam. Ethernet and IEEE standards and speed. Copied. Eight not two means what?
Ethernet.
LAN. LAN. No, 802.3 is Ethernet. 802 is LAN technology section. 802.11 11 is wireless. You see your Wi-Fi, Bluetooth, these all are 802.11. In speeds 11A, 11B, 11G, different will be there. Okay, so when you purchase any mobile phones, if you see the specifications, if you see wireless, you can mention there 802.11. Means wireless is LAN or WAN. What type of technology it is? LAN. LAN. 802 do 802. Whenever you see 802 is a LAN. Okay. Yeah. In entire routing, in routing concepts, so we which device we discussed more? Discussed about router, right? Introduction to router, what is router, types of router, functions of router categories, router types, external components, internal components, router configuration, router interfaces configuration, routing protocols, all about routers we done. Similarly, now we're going to start about switch. What is switch? How it function? How many port switches are available? Like how to connect and how to configure it, and what type of switching protocols need to be implemented on switches, like how it works or how it helps in LAN technologies. Like all about we are going to discuss about switching concepts actually. This is one switch. Switch is which layer device? Router is network layer, which is layer 3 device. What about switch? Switch works under which layer? Switch is layer 2 device. Remember in OSI reference model we discussed layer 3, layer 2, layer 1, network layer, router works, data link layer,
Yes.
switch. So switch is a layer 2 device. Okay. And switches are available in 8 ports, 8 port switch, 24 port switch, 48 port switch, like different ports. Mostly 24 port and 48 port switches will use in real network section. Okay. Yeah. These are Cisco switches. It's clearly showing Cisco Catalyst 2960, 48 ports, 48 port managed switch. This is the box. Here you can see number of ports, 48 ports. On each port, each device you can connect. Your computer, your server, your camera. Like which device you want to add to the network, we can connect it to this through RJ45 ports connected. This type of boxes will available in 24 ports, 48 ports mostly. Clear? Right. So this is one of 24 port switch. And I connected some devices to 1, 2, 3, 4, 5, 6 ports. Let me explain about switch. Switch is which layer device?
Data link layer 2.
It's a layer 2 device. So layer 2 devices works with MAC address. It understands only MAC address actually. Does not understand IP address. How it understand MAC address? It maintains one table called MAC address table. MAC address table. And switch functionality, how it functioning is whenever traffic will come, switch will do flooding. Nothing but a broadcast. But the thing is, switch will not do always the broadcast. It's very intelligent actually. It can support unicast also. Unicast communication. I'll explain when switch will do flooding and when switch will do unicast. And the switch ports we can set speed. We can set speed also. Port speed we can set. And we can manage duplex communication. You want to switch to half duplex, we can configure, or full duplex we can configure. We can set duplex also. So these type of switches are two types. Managed, manageable, unmanaged. So we have seen what here is clearly telling is this is managed switch. Two types, managed, unmanaged. Okay. Point number 1 is a layer 2 device. It works with MAC address and it maintain table called what? MAC table. Say this is the MAC table. What is exactly MAC table contains information? It maintains about port numbers and which port and which MAC address is connected. Port number 1 device connected, that device MAC address is A1. On port number 2, so and so device connected. That device MAC address is V1. Like it maintains what? Port number and MAC address information. But very important point you should remember, by default, your MAC address table is what? Empty, even if devices are connected. Then when MAC table will update, when request starts from any device. So from this device, there is one request started, then this device MAC address will update here actually. A request has started from device, this device MAC address will update here. From this device, there is no request. It is not pinging or any traffic is not generating, then we don't see this device MAC address in MAC table. So MAC table will only update when there is traffic generated from any device actually. Got it? Yeah. See, from first device, request started. So first device trying to communicate with the sixth device. Tell me which one is the source and which one is the destination. I
10.10
repeat,
is a
10 dot
source.
10. Okay, source IP address is 10.10. Destination IP
10.60.
10.60. If only IP is generated to L2 switches, then L2 switches will understand IP address? No, it will drop it actually. So switches will forward the traffic based on what? Based on MAC address actually.
Yes.
So MAC address also should be updated. Of course, it will update automatically here. And tell me, what is source MAC address? I mentioned MAC addresses for each device, right? What is the MAC address of first device?
A1.
A1. And what is destination device MAC address? 10.60 MAC address.
C2.
How we can say destination device MAC address is C2? By seeing the diagram you're telling, right? But how really device know about destination device MAC address? We know IP address. I want to reach to 10.60, but I don't know what destination device MAC address. Agree?
In a real time, how we find the MAC address if you want to route this kind of way?
That is what, like we don't know. We can't find that destination device MAC address actually. That's what I'm trying to explain.
Oh,
Then, if we don't know destination MAC address, then switch cannot be forward the traffic. So switch don't know where exactly I need to send this packet now, right?
Right.
So there is one active protocol will help here to get the destination MAC address. It is very, very important protocol in LAN. That protocol is ARP, Address Resolution Protocol. It is going to be resolve our address. Like what address we know? We know IP address, right? That what ARP will do, using this IP address, it will get MAC address. So what ARP is doing is, in this entire segment, in this entire space, who is 10.60? I want 10.60 MAC address. So ARP will take the job of it actually. What ARP is doing is, it will get 10.60 MAC address and update here. Then switch can know, oh, source is so and so, and destination so and so, and then communication starts. So initially we don't know destination MAC address. We know only IP address. Then ARP will come in the picture to get the destination MAC address. Like how ARP works, and ARP will generate request we call ARP request. Then destination MAC address cannot be empty. Destination MAC address, what ARP is doing is it's adding MAC address is all FFFF. Like 12 hexadecimals. Simply I'm writing here just FF. We call it is broadcast MAC address. All 255, 255.255.255.255 is what? Broadcast MAC address. Sorry, broadcast IP address. The last MAC address is broadcast MAC address, all FFF combinations. So this frame is generated in source device. Now source IP is available, destination IP is available, source MAC, destination MAC. Where this traffic is generated, listen carefully. Where, I mean, on which device this traffic is generated?
Switch.
I'm asking about in device, end device. Which device? PC1. From PC1 traffic
Device one.
generated, right? Yeah, device 1. Now, the traffic will come to switch. Device 1 connect to which port number? Port number 1. So, what is the first action of switch is from where traffic is generated, that device MAC address will update in MAC table. We call it is learning source MAC address. Learning source device MAC address. From which device traffic is generated, it will learning and update to MAC table. So when traffic come to switch, what switch will do? It will learning. Yo, you're coming from port number 1. What is the source MAC address? A1. It will update to MAC table. Port number 1, A1 connected. Done. After learning source MAC address, now switch will look into destination. Okay, now where I need to send this packet? What is destination MAC address? What is destination MAC address?
6.
Destination MAC address.
By default, it's
All FFF means what?
F.
It's a broadcast.
That will be there.
Flooding. Now this packet will go to port number 2, port number 3, port number 4, port number 5. How many ports are connected? I mean, how many ports are in switch?
24 ports.
24.
It will, yeah, it will send packet to all 24 ports. So we call it as a broadcast. One to all ports in the LAN. One more point is if switch 1, if it is connected to switch 2, there is a link, uplink between switch 1 to switch 2, then the same packet will flooding to switch to all 24 ports also. If switch 2 is connected to switch 3, the same broadcast packet will flooding to all 3 switches. 24 into 3, 72 ports flooding. So if you increase your LAN size, your broadcast domain will be increased actually. Got it? Yeah. So first let's understand the broadcast in one switch. Because initially a destination device MAC address is not available in MAC table. Then switch don't know, so which is the destination. That's why it is flooding to all devices. So this packet go to port number 2, port number 3, port number 4 now. So when port number 2 received, now what PC will check? Who is your destination? What is the destination IP? Destination IP address is 10.60, but PC2
Yeah.
IP is what? PC2 IP is 10.20. Then PC2 will say, I'm not your destination. I won't give reply. So it will drop it. PC3 will drop it. 4 will drop. 5 will drop. Then PC6 will respond. Yes, I'm your destination. My computer IP is 10.60 and your destination is also 10.60. I'm your destination. What do you need? It is ARP is requesting for a MAC address. I need your MAC address. Then this PC will give reply. If this PC is giving reply means now which is a source device? What is source device? IP address. Now source is
10.10.
10.60 because this is giving reply now.
Yeah.
Destination IP address is
10.10.
10.10.
10.10. Source MAC address C2. Destination MAC address ARP
FF.
reply. ARP reply. ARP reply to which MAC address?
A1.
A1. Where it is generated? Where traffic is generated? PC6. When traffic will come to PC to switch, what switch will do? What is the first action of switch? Learning source MAC address is learning source. What is the source MAC address? C2. Which port number it is connected? Port number 6. After learning source MAC address, not look into destination MAC address. What is the destination MAC address now? ARP reply. ARP reply to which MAC address? A1. So do you have A1 information MAC table right now?
Yes.
Yes. So is there a need to broadcast again now? No.
No.
Because initially destination device MAC address is not available MAC table, then it is a broadcast. ARP will come in the picture. Now no need. Because destination is A1. A1 is already available. Which port number it is connected? Port number 1. So it will reply directly to port number 1. We call it as unicast communication. So as per your understanding, then tell me when switch will do broadcast, when switch will do unicast. Yes, please.
When MAC
The
address is
destination
available
it will
in MAC address table, it uses
Correct.
unicast packet.
Yes, perfect. When MAC address, I mean destination device MAC address is not available MAC table, then
Broadcast packet.
broadcast by using which protocol will come in the picture?
ARP protocol.
ARP. Excellent, right. Simple logic. If destination device, your destination is a so-and-so FTP server, that destination device MAC address is not available. Broadcast. ARP will come in the picture. Your destination is so-and-so printer. You are giving the printer is a destination. You are making one print. The destination device MAC address is not available. Broadcast. Your destination is a HTTP server, but destination device MAC address is already available. Then directly unicast you can communication. So switch will do broadcast or unicast depends upon the MAC table. If destination device is MAC address is available, unicast is not available, broadcast. ARP will come in the picture actually. Clear? So in MAC table, port number 2, port number 3, port number 4, port number 5. Port number 2 MAC address is B1, port number 3 is A2, port number 4 is B2, port number 5 is C1. Now all connected devices MAC addresses are updated in MAC table. Then tell me what type of communication happens in this switch? What type of communication? Broadcast or unicast? So all devices, 6 devices MAC addresses are updated in MAC table. Then what type of
Unicast.
communication?
Yes.
Unicast. Because all devices MAC address available now. Unicast actually. One-to-one communication. No, here very important point is after some time, any one device, example PC3. So PC3 is not generating any traffic. It is just idle in network, or it might be shut down. Something. It's not generating any traffic actually. You know what switch will do? That port number 3, A2 MAC address can hold up to 300 seconds. Up to 300 seconds. Up to 300 seconds if there is no request. If traffic is not generating, request is not generating from the port number 3, then switch automatically will flush. You're not in network, you're not generating any traffic, then why I need to maintain your? It will remove. Your MAC address port number is automatically flushed in MAC table actually. So switch can hold aging time. Switch can hold how many seconds?
300 seconds.
300. If continuously the traffic is generating, then it maintains actually. If traffic is not generating for 300 seconds, then your MAC is flushed. Okay. A2 is not available right now, but remaining MACs are available. They're working actually, Now B1 want to communicate with A2. What type of communication starts?
Broadcast.
Broadcast to how many ports?
Hmm.
All 24 ports. Broadcast message itself is one to all. All 24 ports. If switch 1 connected to multiple switches, and multiple switches are broadcast. So because of one device is impacting in all ports actually. Agree?
Yes.
So this is how switch works. If switches is doing this type of broadcast, then users will experience the slowness of the network. Connecting, disconnecting, connecting, network down. So frequently you can get a complaints. So my internet is sometimes I'm getting network, sometimes it's getting failed because of the broadcast. So these broadcasts as a network team, as a network engineers, we need to manage it actually. Switch, you should not do like this. Why you're broadcasting to all 24 or all 72 or all 100 ports? No. We can segregate the broadcast in departments wise, sections wise, projects wise. There are hundreds of switches are interlinked and different departments are connected. Any one of the device broadcast generated is going to impact in all project actually, all departments. Why? No, we'll segregate. Logically, we'll segregate. I'll tell you later about that concept. So we need to manage that broadcast actually. That can be possible with the help of this switch.
Managed switch.
So that is a major difference between managed and unmanaged. The name itself is telling is that managed. We can manage the broadcast. We can minimize the broadcast actually. If broadcast is minimized, then users experience like user faster communication. Your network performance is improved and secured also. No impact on the network. Got it? If manage the switches, we can assign the IP address. We can configure IP address. We can enable telnet functionality from remotely. We can operate it. So simple. Managed, unmanaged. Difference is in managed switch we can configuration. We can configure it. We can implement protocols. We can write policies. We can enable telnet functionality, remote login. All configurations can be done. If it is unmanaged, just connected your devices, plug and play type. Just can start communication. We cannot configure actually. Got it? Then how to identify this switch is managed or unmanaged? Here name is there, managed. But by seeing the physically, how we can tell it is a managed or unmanaged? Then first tell me what is the difference between managed and unmanaged?
It might be a controlled something by control.
No, just tell me the differences between managed and unmanaged switch.
Can be configured and cannot be configured.
Can be configured. Then you have purchased one managed a brand new switch. How we can configure initially? Which port do you want to use?
Console port.
Console port. So that's all. It can be any vendor. If you see console port, it is a managed switch. It can be any vendor. If no console port is unmanaged. So by seeing the console port, we can identify it is managed or unmanaged. It can be any vendor, Cisco, D-Link or HP. No, any switches. Dell switches. If there is a console port, it is a managed. We can manage it. We can configure. Connect a console cable and we can do manage that. Got it? Manageable switches on a manageable switch, IP address can be assigned and configurations can be made. It has a console port. Unmanageable. Unmanageable switch configurations cannot be made. IP address cannot be assigned. There is no console port. So by seeing the console port, we can identify is it manageable or unmanageable. Clear? In Cisco routers, we have discussed about categories. Remember 2600 series, 5000, 5500, 6000, 9000 series, different, majorly three categories: branch router, network edge router, ISP routers, three categories actually. And we know what is the differences also. More similarly, switches, the Cisco uses three terms to describe the switch role of the switch: access layer switch, distribution layer switch, and core layer switch. Three terms, three layers: access layer, distribution layer, and core layer. Basically, switch comes under which layer device? In OSI, switch is a which layer device?
2.
Layer 2. What is the layer 2 functionality? Layer 2 devices works with only MAC address. It cannot understand IP address. Means layer 2 switches can only enable communication between the same network. There is no mechanism to enable communication for different networks. Different networks communications ultimately will require which device? Layer 3 device. What is the layer 3 device? Router.
Right.
Yeah. But point is here, you're all in devices, means computers, your servers, your scanners, your printers, your CC cameras, like all end devices we called are connected to access layer switches. So access layer switches is generally used for connectivity purpose. Your all end devices are connected to access layer. And access layer connected to distribution layer. So distribution layer, we can write the policies here actually. Mostly all policies, all rules, all configurations can be made in distribution. So distribution layer switches purpose is what? How these access layer switches ports should be work. We write the policies here actually. Based upon the configurations, based upon the policies, what we made here, your all end devices can be functional. And distribution is connected to core switch. So core switches are fast processing purpose. We don't configure any policies here actually. This is for faster processing. There are different layers, hierarchy design. The point is access layer switches are layer 2 switches, whereas distribution and core layer switches are, we call it is layer 3 switches. What is layer 3 switch? Actually switch works in layer 2, but we call it as layer 3 switch. What is layer 3? Network layer. So means these switches works in the layer 3, means network layer. So these switches are router cum switch, two functionalities. We call multi-layer switch. So if you have a distribution layer or core layer switch in your network, then router is not required. Because in distribution switch or core switch, we can configure all routing algorithms, routing protocols. So these devices can enable communication between two or more different logical networks. So these devices can implement static routing, like dynamic routing protocols. So distribution core layer switches works as a switch as well router also. In the small organizations, we use layer 3 switch. We purchase one layer 3 switch, connect your 20, 40 devices. Then separately no router is not required now. If you want to implement routing policies, you write in this switch only. No need to maintain a separate router, separate switches, not like that. But in a corporate networks, we maintain separately switches for switching purpose, routers for routing purpose. Getting my point?
Yes.
So by seeing the console port, we can identify whether it is managed or unmanaged switch, correct? Then how we can identify layer 2 switch or layer 3 switch? Tell me this switch is a managed or unmanaged. By seeing console port, you can understand is a managed or unmanaged. Agree? But tell me this device, is it a layer 2 switch or layer 3 switch? How can get to know? So how we can understand this router is a branch router, a network edge router, ISP router? How we can identify this is router, this router is it a branch router or network edge router or ISP router? How? Model numbers, right? 2600 series, 2800 series, all are similarly switches also. Access layer switch, distribution switch, and core layer switch. Series 1900, 2950, 2960. Clear? Initial configuration of switch, like how can configure switch. Do you know how to configure router? If you know how to configure router, then you can come to know how to configure switch also, because both are same. 2960 switch I'm using. Connecting 7 devices. Straight cable from PC fast Ethernet to, if you click on switch, it shows us how many ports switches are available. How many ports are available in the switch? See, there is a console port. It means, is it managed or unmanaged?
Managed.
Managed. And here we have 24 ports. So I'm starting with port number 1. Or you can use automatic cable. Port number 2. Port number 3. Port number 4. Port number 5. Port number 6. Port number 7. Click on switch, CLI. Like how we configure router, same like a switch, because routers and switches works with IOAs only. Same modes, user mode, privilege mode, global config, and commands, almost. See, switch user mode, enable, switch privilege mode, show version, show running config, show run, show running config, all commands. What we command, the same commands. So config terminal, host name, example, switch A. The difference is assigning IP address switch ports are different actually. How I can assign IP address? We don't assign IP addresses for ports actually. We assign virtual interface. We call it is interface VLAN, virtual LAN. Default is 1. Interface VLAN 1. For VLAN 1, we assign IP address. All ports, all 24 ports in the part of VLAN 1 only. 192.168, 1.1, 255.255.250. No shutdown. So VLAN 1 is a part of all ports, all 24 ports in the part of VLAN 1. So VLAN 1 IP address is which IP address? Yeah. Show MAC hyphen address hyphen table to open this MAC table. So default MAC table is empty because from the device request is not generated. If you generate any request, your MAC table will update actually. So if you generate any traffic from device, your MAC table update. Let us assign IP address first for the end devices. Then you can generate any request. 192.168.1.10. .11. You can generate any traffic. Ping 192.168.1.11. Request generated. Now if you check, show MAC table. So port number 1, port number 2 is updated actually. So on MAC address. Like assign IP addresses to all devices and generate some request. Any traffic you can generate, ping traffic or web traffic, any traffic you generate, the MAC table will update. Got it? Yeah. So it's all about for today. So we're done with introduction to switching concepts. Tomorrow we'll continue with some more advanced topics in switching, like how to minimize the broadcast in the network by segregating the network, creating VLANs, implementing VLANs. So VLANs concept will start talking about. Thank you. Have a good day.
Thank you.
Thanks to all.
Thank you.
Thank you.
Yeah, thanks, man.